So main topic is chemical reactions and the subtopic is the redox. So as we have already discussed the concept of the redox reaction, the reaction in which both oxidation and reduction take place at the same time, we call them as redox reaction. Like you will remember this from oil rig, where O stands for oxidation, I stands for is, and L is for loss. And R is the reduction, is the gain. But gain or loss of what? It is because oxidation and reduction we can define in three ways. Number one, we can define in terms of oxygen, we can define in terms of electrons, and we can also define in terms of oxidation number. So first definition of oxidation and reduction in terms of electron. So in terms of electron, oxidation is a loss of electron, and the reduction is gain of electron. So when something will lose electron, we call oxidation, and it gain electron, we call that as reduction. Example, so we have a zinc atom, and this zinc atom, so we have zinc atom, it lost electron, it loses electron and turn into zinc ion. So whenever element or a substance losing electron, what we call this change, we call that as oxidation. So we'll say zinc oxidation happened for zinc, or zinc is oxidized. Whereas the concept of the reduction is a gain of electron. Like example, if there is a copper ion, it gain electron and it turn into a copper atom. So as it gain electron, what we call this change? We call this change as reduction. So oxidation is a loss. The first definition, there are three ways we can define oxidation or reduction. The first definition is in terms of electrons. So definition in terms of electron, oxidation is loss of electron, reduction is gain of electron. The second definition is there in terms of oxygen. The second definition in terms of oxygen, so oxidation is actually addition of oxygen, and reduction is removal of oxygen. So when oxygen is added to something, we call oxidation, and if oxygen is removed, we call that as reduction. So example, we have copper oxide is there, and it reacted with carbon monoxide. As a result, the copper oxide turned into copper metal and carbon dioxide is formed. Now we want to check in terms of oxygen, because the second definition is in terms of oxygen. So we want to check which substance is oxidized and which substance is reduced. So for that we have to check the changes here. Like when we check the first part, first it is copper oxide and then it turned into copper. So when copper oxide turned into copper, what it shows? it shows that oxygen is removed. So when oxygen is removed, what we call removal of oxygen, we call that as reduction. So this change of copper oxide to copper metal, we call that as reduction. And when we check the other part, the carbon monoxide, first it is carbon monoxide and then it turned into carbon dioxide. So when we are checking a change, first there is only one oxygen, but then there are two oxygen. So it means oxygen is added. And when oxygen is added, what we call this change? We call this change as oxidation. So oxidation is addition of oxygen and reduction is removal of oxygen. Is it clear, this example? The second definition in terms of oxygen. So we can define oxidation or reduction in terms of electrons. We can also define in terms of oxygen. Then the third definition we can also define in terms of oxidation number. What is the oxidation in terms of oxidation number? What is the definition? If oxidation number increase, we call oxidation. And if oxidation number decreases, we call that as reduction. And what is the oxidation number? Oxidation number, it is a charge, it's according to the group number. So it is charge appear on elements when they form a compound. So when elements are forming a compound, the charge will appear on them, which also we call as a valency, if you remember, the valency or the charge. So it is a charge, or we can also say a valency, appear on the element when they are forming a compound. Group 1 valency +1, group 2 +2, group 3 +3, and so on. So this is the table, the periodic table. So if we have element from group 1, we call that as +1 valency, +2, group 3 will be +3, group 4 is -4, -3, -2, -1, and 0. So these are the charges which appear on the element. We call them as valency, or also known as oxidation number. So how we can work out whether the change is oxidation or a reduction? And valencies only appear on when the elements are forming a compound. When elements are existing, like example, if I say we have sodium chloride, NaCl. So what is the valency of sodium? You will check the periodic table for sodium chloride. We'll check the periodic table. So sodium is group 1. Sodium is here group 1. So what will be the valency of sodium? +1. Valency or oxidation number. Yeah, that's right, Abdullah. And group 7, chlorine, what will be the valency or the charge? That is -1. So when we write the valency, valency is a charge appear on atom when it is forming a compound. So sodium is +1, chlorine is -1. But when we write them as element, like example, if I write alone Na, if I write Cl2, so what will be the valency of the element? Valency of all the element is 0. Like valency is the charge appear when they are forming a compound, when they combine with another atom, element or atom. But when they are in element form, the valency is, or the oxidation valency or oxidation number, that is 0. So example, if there was a reaction that sodium is reacting with chlorine to form sodium chloride, NaCl. Equation must be balanced. First, this is NaCl, so we put 2 here, so equation is balanced. Now we want to identify in this question, we don't see a charge, we don't see any electron, we don't see oxygen. So how we can identify the change as oxidation or reduction? So we have to use our understanding of oxidation number. When elements are there, elements oxidation number is 0. Like sodium is an element. What will be oxidation number? 0. Chlorine is an element. What is oxidation number? 0. But sodium chloride is a compound. Compounds, the element oxidation number is same as their valency. So sodium is group 1, it will be +1. And chlorine is group 7, it will be -1. So when we check the changes here, so sodium is 0, it changes to +1, and chlorine is 0, it changes to -1. So what happened to oxidation number during a reaction? What happened to oxidation number of sodium? It was 0 initially and then it become 1. So it increase or decrease? 0 become 1. So it increase. So whenever the oxidation number increase, so sodium element state, it was having oxidation number 0. But here what happened? Oxidation number increases. If oxidation number increase, what we call? We call that as oxidation. So whenever there's an increase in oxidation number, we call that as oxidation. And opposite, as you can see, for chlorine, it was 0 become -1. So it is a decrease. Whenever there's a decrease in oxidation number, what we call? We call that as reduction. So here, oxidation number decrease. And if oxidation number decrease, we call this change as reduction. So when a question is there, depends on the question. Sometimes electrons are given and they ask to identify oxidation or reduction. Sometimes oxygen is given, they ask identify oxidation or reduction. And sometimes there is no electron charge or oxygen is not there, and you have to identify oxidation or reduction. So you will use a periodic table to work out the oxidation number, and using the oxidation number you can tell that whether it's oxidation or reduction. If the number increases, we call oxidation. If the number decreases, we call that as reduction. Is it clear, this example? That how we can identify whether oxidation or reduction using the oxidation number. Oxidation number is a charge appear on element when they form a compound. Any doubt till this point? I'll give more examples to improve your understanding, but this is a basic idea that when oxidation or reduction happen, it can be defined in 3 ways: in terms of electrons, in terms of oxygen, and in terms of oxidation number. So when we are explaining the concept of oxidation or reduction, so explaining the concept of oxidation and reduction, there are 3 ways. Sometime they give you the electrons or charge, sometime they give you the oxygen, and sometime oxidation number. So in terms of electrons, in terms of oxygen, or in terms of oxidation number. So if it is in terms of electron, oxidation means loss of electron. Reduction means gain of electron. In terms of oxygen, addition of oxygen is called oxidation, means addition of oxygen, and the reduction means removal of oxygen. And in terms of oxidation number, oxidation means increase in oxidation number, and reduction means decrease in oxidation number. So these are the definitions which you have to learn and you have to identify in terms of depending on the question. Sometime electrons are there, sometime oxygen is there, and sometime the charge is given or oxidation number is given. So now we'll do some different examples, and I will mix all the examples so that you can sort out which technique we will use to identify oxidation or reduction. Example, there was zinc reacted with copper ion, form zinc ion and copper metal. So first thing, if we try to check in terms of electron, whether it's a loss or gain of electron, we cannot identify, like, because there are three ways to check whether it is oxidation or reduction. Number one is in terms of electron directly. Electrons are not shown here. Number two is in terms of oxygen, and number three is oxidation number. So I cannot see any electrons, even electrons loss or gain, but in the equation it's not given. So I cannot directly identify in terms of electron. When I try to find oxidation or reduction in terms of oxygen, so again, oxygen, there's no oxygen involved here in a chemical reaction, so oxygen we cannot use. Now we are left with this oxidation number. So now we have to check the oxidation number. So zinc is element here, and here zinc is ion. For ions, the oxidation number is same as the charge. For elements, oxidation number is 0. So when it's an element state, their oxidation number is 0. But when their ions are there, the oxidation number is same as the charge which appear on the ion. So in the first part, zinc element is given, zinc atom is given, so it is 0. What is the oxidation number of copper? So it is +2 because it's an ion. So the charge is same as oxidation number. For zinc ion, the charge is same as oxidation number, and for copper element, oxidation number is 0. Now we want to identify the changes, whether it is oxidation or reduction. So when you check zinc, it was 0 become +2. If 0 become +2, what happened to oxidation number? 0 become +2, increase or decrease? Originally it was 0, but now it changes to +2. So it increase, whenever there is an increase in oxidation number, what we call this change? We call this change as oxidation, because oxidation number increases. And when you check for copper, it is +2 changed to 0. +2, originally it was +2 and now it changed to 0. What we call this change? If +2 becomes 0. So because there's a decrease in oxidation number, and whenever there's a decrease in oxidation number, what we call this change? We call this change as reduction. So it can be a change, a chemical change can be oxidation or reduction. As for zinc, atom changes to zinc ion. So oxidation number increases, we call oxidation. And for copper atom, copper ion change to copper atom, the charge, the oxidation number on the copper decreases. That's why we call this change as reduction. Is it clear, this example? So why we did not use electron or oxygen here? Because it was not given. So if electron and oxygen are not given, then we work out in terms of oxidation number. So another example, if we say we have uh, calcium plus magnesium oxide, and it turned into, the oxidation number can be used for any kind of reaction, like even it's not involved, because we can, using a periodic table, we can write the oxidation number. So oxidation number is like universally it can be used for any kind of equation. So it turned into calcium oxide plus magnesium. Now we want to identify which change is oxidation, which change is reduction. So there are three ways to check. One is by electrons, one is by oxygen, another one is by oxidation number. Oxidation number is valid, like it can be used for any kind of chemical reaction. So when we check the first, electron, but we don't see any electrons transfer, so that's why we cannot do with electron. Oxygen, yes, we can see the oxygen, so we can work out in terms of oxygen. And oxidation number, you can also use oxidation number and you can get the answer. So now if we check with oxygen, so we'll recognize, identify the changes. First it is calcium, then it is calcium oxide. So for calcium atom change to calcium oxide, it means oxygen is added. Originally it is calcium, but then it turned into calcium oxide, so oxygen is added. And whenever oxygen is added in terms of oxygen, that change in which oxygen is added, we call that as oxidation. And opposite, if we have magnesium oxide turn into magnesium atom, so first it was having oxygen, and then the oxygen is removed. So oxygen is removed from this, what we call removal of oxygen, and removal of oxygen is known as reduction. So we can identify in terms of oxygen, as in the question, oxygen is given. Is it clear? This example, how we work out oxidation and reduction in terms of oxygen. Any doubt till this point? So oxidation, it's a gain of oxygen, and reduction is loss of oxygen. Or oxidation in terms of electron, it's a loss of electron, and reduction is a gain of electron. Some more examples related to oxidation and reduction. So if we say we have Mn plus 7, it gain 5 electron and it turn into Mn plus 2. What is this change called? Mn plus 7. So we want to identify, because there are different ways to identify a reaction. We can check in terms of electron, we can check in terms of oxygen, and we can check in terms of oxidation number or the valency or the charge. So electron is shown here, so we can use electron. Oxygen cannot be used because there is no oxygen involved. Oxidation number is valid for all the reactions. All the reactions we can work out, solved by oxidation number. So when you check Mn is plus 7, it gain electron or it take electron and it turn into Mn plus 2. So what we call this change, oxidation or reduction? It's a gain of electron. Mn plus 7 become Mn plus 2. What we call this change? Oxidation or reduction? Oxidation is a loss of electron. Remember from oil rig, oxidation is a loss of electron and reduction is a gain of electron. So what happened here? Mn plus 7 take 5 electron, gain 5 electron and turn into Mn plus 2. What we call this change? So because it's a gain of electron, whenever it gain electron, we call that as reduction. And there are certain elements which changes the color. When the oxidation number changes, they changes the color. So you have to learn few of them, but there are different elements which changes the color as oxidation number changes. The one which you have to learn, remember, whenever Mn or manganese is plus 7, the charge is plus 7, it is purple in color. This you have to memorize the color. And Mn is plus 2, it is colorless. So Mn plus 7 will change into Mn plus 2. So it will change whenever the sum, it's not happen for all the elements that oxidation number changes, that color also change. But for few elements, it happen that when they changes oxidation number, the color will also change. For in case of Mn manganese, it is, if the manganese it's plus 7 oxidation number, it is all, the substance will always be a purple in color. Pink is acceptable, purple is also the right, because it's high concentration manganese, it will be purple, low concentration it will be pink. And it changes into Mn plus 2, so Mn plus 2 is colorless, so it will change from purple to colorless. This you have to learn the color. Another one which you have to learn is chromate Cr plus 6. If it gain electron, it turn into Cr plus 3. So chromium is there, which is plus 6, it gain electron. This change is also reduction. So chromium plus 6, what is the color of chromium plus 6? It is orange or yellow. And chromium plus 3 is green in color. And this also you have to learn. The color of the chromium plus 6 is orange or yellow is acceptable. And it turned into chromium, if it turned into chromium plus 3, it will be green in color. And the last one which you have to learn the color is iodide. When iodide loses electron, turn into iodine atom. When two iodide are there, they will lose two electron and form iodine molecule. So because it's a loss of electron here, it gain electron, that's why we call that as a reduction. And here iodide ion is losing electrons, so we call that change as oxidation. And whenever it's an oxidation, because it's a loss of electron, due to that it is oxidation. Now the color which you have to learn, iodide ion is colorless, does not have any color, but iodine molecule, it can be brown. If it is high concentration iodine in water, it will be brown, or if it's a low concentration iodine, then it will be yellow. So these colors you have to learn for three of them. One is manganese, which is purple and colorless. Another one is chromium, which is orange yellow to green. And the third one is iodide. When it changes the oxidation number, the color also changes. So it changes from colorless to brown or yellow. Brown if it's more high concentration iodine, and yellow when it is low concentration iodine. So sometimes they give you the equation and they ask for color change. You don't have to write both brown or yellow, either brown or yellow. Both colors are accepted. You don't write brown yellow. You will write either brown color or yellow color. So example, if I say Mn plus 7 reacted with 5 chloride ion, or reacted with chloride ion, this Mn plus 7 change to Mn plus 2 and it will form a chlorine molecule. This equation is not balanced. I just use numbers to explain the idea. The first thing they ask, identify oxidation. So how we can identify oxidation? As there is no electron given, there is no oxygen given, so we'll use the oxidation number. Oxidation number for ions, the charge written on the ions is known as oxidation number. So Mn is plus 7, it changes to Mn plus 2, and chlorine is minus 1, it changes to 0. So it's plus 7 changes to 2, and minus 1 changes to 0. Why 0? Because when elements are there, their oxidation number is 0. So the first change, there is a decrease in oxidation number. And the second change, there is an increase in oxidation number. How it is increased? Because it was minus 1 becomes 0. Like minus 1 becomes 0 means increase is there, because 0 is greater than minus 1. So when we work out which change is oxidation, the first one, Mn plus 7 change to plus 2, what we call oxidation or reduction? What we call this first change, Mn plus 7 change to Mn plus 2. There's a decrease in oxidation number. What is the name given to this change? Oxidation or reduction? So it is a reduction because the charge is decreased, so we call that as a reduction. And if for chloride, the charge increased, so we call that as oxidation. So identify oxidation, which substance oxidation happened, that happened for chloride. And identify the reduction, for which substance reduction happened. So Mn plus 7 So how we can identify the reduction? Reduction happened for Mn plus 7. Then they ask, state the color change. So how we can work out the color change? We know that Mn plus 7, it is purple in color. So this Mn plus 7 is purple, where Mn plus 2 is colorless. So what is the observation? What we'll see when this reaction occur? We'll observe or we'll see the purple color will disappear. The purple color will turn colorless, or you can say the purple color will disappear. Is it clear, this example of oxidation and reduction? So you should be able to identify oxidation, reduction, as well as the color changes. Only three you have to learn. One is the color for Mn plus 7 and plus 2 equation. The other one is chromium, and the third one is iodine. So I'll share another link and continue this discussion.